Hi, I'm Changyol Lee, and today we continue to re-interview of the fundamental of physics device. And first, we learned this silicon wafer method. So, in the preceding of setting, we made the ingot to and making the wafer and polishing it uh, and doping of semiconductor material. We learned about the important term of the Fermi rebel. So first, we to make the Fermi rebel, we discussed about the thermal equilibrium, uh, thermal equilibrium, and second, variable constant will be make it so in the middle of the uh, conduction band and balance band, the depletion region, such like space charge region, are be made it. So uh, mm, made it so we can tell about the Boltzmann tail, about Fermi distribution and density of states, so we can make the Boltzmann tail like this. And it is important to discuss about the Poisson equation. First, the y-axis is the charge, so we integrated them and we can get a electric field. So the middle of the depletion region, the electric field max is this point, and we also integration one more. The potential graph is seems like this, and PN diode part, uh, the built-in voltage is the barrier of the energy band. So this point is the built-in potential. Built-in potential minus some bias. We get the junction potential like VJ, and such like reverse bias, forward bias, and we can drawing a graph like this at the PN diode. And at the part of the MOSFET field effect, metal oxide semiconductor field effect transistor, the basic concept of the MOSFET is the MOSCAP, and accumulate part, depletion part, and the inversion like this part. We can show about the in the MOSCAP. We learned about the important formula over the MOSCAP. So like it's like VG equals flat band voltage, oxide voltage like potentials, and phi s, and inversion charge like IMV equals because of the charge Q equals CV, the best important formula. So we get Q inversion equals C ox VG minus VT, such like overdrive voltage, and the threshold voltage VT means flat band voltage plus minus Q depletion over C ox plus 2 pi B, and we can learn about the IG VG VDS curve and ID VDS. So we learned about the MOSFET, and today's semiconductor we use complementary MOSFET like CMOS. So why the CMOS is important and why CMOS is using today's semiconductors industry. So we learned about the logic gate about to express the CMOS conduction, and today's MOSFET we use SOI and FinFET device, because about the MOSFET industry is still developed, and SRAM and DRAM like memory devices can also cause. So SRAM is the latch structure. 6 transistor is one cell, high speed, static when power is applied, lower power dissipation, and DRAM is less speed, slower than SRAM, but one transistor, one capacitor structure, and slow. Refresh is needed. Higher power dissipation, and flash memory non-volatile. And today Samsung use still develop about the V NAND.